All right, today we're pulling back the curtain on the secret engine that powers pretty much all of modern AI. And no, it's not some wild new algorithm or a super fast chip. It's something way more fundamental, the careful human-driven work of data annotation. Let's get into it.
So, have you ever really stopped to think about this? How does a self-driving car know that's a person and not a lamppost? Or how can a medical AI even begin to spot a tiny problem on an X-ray? It seriously feels like magic, right? But what's really going on is this fascinating process of teaching the machine, one tiny label at a time.
To really wrap our heads around this, let's just start with the AI that's all around us, the stuff we use every single day, probably without even thinking about the incredible work humming away in the background.
I mean, think about it. Your voice assistant somehow understanding the new slang you just used. An autonomous car telling the difference between a stop sign and a red billboard. A doctor's AI assistant flagging a tumor that might be almost invisible to the human eye. Or, your favorite shopping website knowing exactly what you want to buy next. All of these amazing things are built on the very same foundation.
So what is that common thread? What's the secret ingredient that makes it all work?
Well, the answer isn't just having a ton of data. That's a myth. It's about taking all that raw, messy, chaotic data and having real people carefully and sometimes painstakingly label it to give it meaning, to give it context.
So here's the bottom line. Data annotation is basically how we teach an AI. Imagine you're trying to teach a computer what a cat is. You wouldn't just throw a million random images at it. No way. You'd show it thousands of pictures, and in every single one, you'd carefully label the pixels that are the cat. Here are its ears, this is its tail, those are its whiskers. That whole labeling process, that's data annotation.
And the amount of effort this takes is just staggering. An MIT study found that data scientists spend up to 80% of their time, let that sink in, 80%, not on coding some fancy new algorithm, but on this foundational, super time-consuming work of just getting the data ready and labeled. It really is the bedrock of the whole industry.
Okay, so how does this labeling actually happen? What does it look like in the real world? Let's take a look.
You might picture someone just drawing simple boxes around cars and photos all day. And yeah, that's part of it. But the world of annotation is way more diverse and sophisticated than that, with all sorts of different methods for different jobs.
This chart breaks it down perfectly for images. You've got your simple bounding box, which is great for just knowing an object is there. But what if you need to know the exact shape of a weirdly shaped building or a tree? That's when you use polygon annotation. And then for something like a self-driving car that needs to understand every single pixel, this is road, this is a sidewalk, this is the sky, you need something called semantic segmentation. The level of detail is just incredible.
And of course, it's not just about images. For an AI to get a handle on human language, we have to annotate text. We teach it to recognize entities, like Apple the company versus Apple the fruit. We tag customer reviews to figure out sentiment. Is this person happy or angry? And we label user commands to figure out their intent, like when you say book a flight.
And that brings us right up to today, to the cutting edge with large language models. For these, annotation gets even more complicated. It's about teaching the AI to reason, to follow really nuanced instructions, and, most importantly, to be safe. This is where human judgment becomes absolutely essential.
The whole process is actually super structured. You start by collecting and cleaning up the data. Then, and this is key, you create crystal clear guidelines for the human annotators. After the labeling work is done, there's a huge quality assurance step to make sure everything is accurate and consistent. Only then is the data finally ready to go train the model.
So, because this process is so absolutely vital for AI, it has basically spawned a massive and rapidly growing global industry.
So check this out. As of 2023, the market for data annotation was already a massive $1.6 billion. But honestly, that's just the warm-up.
Because look at the forecast. By 2032, that number is expected to explode to over $8.5 billion.
This chart really just puts that insane growth into perspective. What does this mean? It means a huge surge in jobs and companies in a field that most people have never even heard of. The demand for high-quality human-labeled data is just going through the roof.
This boom forces companies to make a really big choice. Do you build your own team in-house? That gives you tons of control and better security, but man, it's expensive and really hard to scale up. Or do you outsource it to a company that specializes in this? That's way faster and cheaper, but you give up some of that direct control. It's a huge trade-off with no easy answer.
And it's definitely not a walk in the park.
The work is expensive, making sure the quality is consistent across millions of labels is a constant battle, and as the amount of data just keeps growing, simply managing the whole process becomes a giant headache. And that's not even getting into the critical issues of data privacy and security.
So where is all this heading? What does the future of this human-machine partnership actually look like?
Well, the work itself is changing. It's shifting away from those simple, repetitive tasks and moving toward really complex, judgment-based work. We're talking about things like ranking how good an LLM's answer is, evaluating text for subtle bias, or applying safety labels based on really complex rules.
And this quote just nails why this is so important. In a field like healthcare, the margin for error is basically zero. A bad label isn't just a data point. It can impact someone's health. It's about patient safety. This shows why skilled, careful human oversight is becoming more important, not less.
And that is really the ultimate takeaway here. It's this wild paradox. The smarter and more powerful our AI gets, the more we actually need human wisdom, human judgment, and human values to guide it and keep it on the right track.
Which leaves us with this final, really critical question. As we build these incredibly smart AIs, who teaches them? Who teaches them to be safe, to be fair, and to be wise? It's not a single person or company. It's all of us. Through the quality, the care, and the intention we put into the millions and millions of labels that shape how AI sees the world. That's the challenge and the opportunity ahead.